This is Mr. Precella, and we're going to continue reviewing for the final exam today. We're up to problem 23, where we are factoring a polynomial into linear factors. That means no exponents. Linear, that's how normally when we factor our trinomials with trial and error. Those are all linear factors, given that k is a 0 of f of x. So given a 0, how do we factor this thing? We're going to factor it, since there's an exponent of 3, we should expect 3 sets of parentheses in our answer. Just like when we factor quadratics, aren't there always 2 sets of parentheses? So to get started, you're going to do synthetic division. K equals 3. Now remember to set these up. Synthetic division. 3, negative 5, negative 16, and 12. It's taken 3 lines. If this were notebook paper with lines that I was using here. And y'all remember the pattern for synthetic division? Carry down that first number. And 3 times 3 is 9. Negative 5 plus 9 is 4. 4 times 3 is 12. Negative 16 plus 12 is negative 4. Negative 4 times 3 is negative 12. 12 minus 12 is 0. I feel very confident in this, that I didn't make some little arithmetic error, because we were told that k is a 0. That means we better be getting a 0 right here. This last number is the remainder. This number is the constant. Do you remember how to put the variables in here? You decrease the exponent by 1. If you started with x to the third, this would be an x squared, then an x, and there's your constant. So we were going to write out a strategy on how to do this problem. You first do synthetic division. Now your answer is going to have 3 sets of parentheses. One of those sets of parentheses is x minus k, is always one of the sets of parentheses. I always write that one first. There's no reason you have to. Is always one of the sets of parentheses. To get the other 2 sets of parentheses, factor the quotient. Okay? To get the other 2 sets of parentheses, factor the quotient. So one of my sets of parentheses is x minus k, so we'd say x minus 3. Notice when you're going from k equals to a statement with x, the sign's changing. Okay? So now I need to factor 3x squared plus 4x minus 4. Let's see, let me write it a little neater. Let's see, numbers that multiply together to give 3. Well, there's 1 times 3. Numbers that multiply together to give 4, there's 1 times 4 and 2 times 2. Draw my 2 sets of parentheses. It's now just a factoring problem. And let's see, well, there's not many options for 3x squared. It's going to have to be x and 3x. And let's see, well, for 4, either 1 times 4 or 2 times 2. What's it going to look like? I think it's going to be 2 and 2. Since the second sign is minus, that means there's going to be a plus and a minus. If we look at the outer and inner terms, that's what these marks are. What I'm making right now is the outer and the inner. When you're foiling, we have a 6x and a 2x. I want a positive 4x. So let's figure out how to put the plus and the minus in order to get a positive 4x. I would need the 6 to be positive and the 2 negative. That do it? So in this first set of parentheses, the x and the 2, would that be a plus here and a minus there? So see how I factored that? So I don't really have room to write the answer here, so I'm just going to write it right down here and circle it. First set of factors is x minus k. I say first only because that's the one I write down first. Then the other two are x plus 2 and 3x minus 2. And that's what I would type in here, the 3 sets of parentheses. Okay. So do synthetic division. X minus k is always one of the 3 factors. To get the other 2 factors, or 2 sets of parentheses, factor the quotient. And that's what I was doing here, factoring the 3x squared plus 4x minus 4. Any questions? Oh, okay. Number 24 is another one of those. So we get a chance to practice it again. Oh, I like it better because it doesn't, I have more room up here to write the 3 sets of parentheses. So I'll go ahead and write the 3 sets of parentheses. 1, 2, 3. We already know one of those sets of parentheses. What's one of them? Well, x minus k is always one of those sets of parentheses, but it doesn't say k equals. Do y'all remember, if it doesn't say k equals, what's the k here? Yeah, the number that you're given, that's 0. Okay? So we could go ahead, I'm going to write k equals -3. The 0 that's given, that's the number we'll use for k. So write off x minus k. So you'll see why I put a plus there. X minus a -3, so x plus 3. Notice when you're going from just k equals to x, the signs on the number are changing. And let me go ahead and write down 4, 7, -14, 3. If we do this right, we know what this number is going to be right here. What's that number going to be at the very end? This last number here. Better be 0. Okay? That's -3 is a 0. So carry down the 4. 4 times -3 is -12. 7 minus 12 is -5. -5 times -3 is 15. -14 plus 15 is 1. 1 times -3 is -3. So yeah, we did get a 0 there. So the thing we're trying to factor is put in the variables. It would start with x squared, x. That green 1 is just the constant. So that's the thing I'm factoring there. 4x squared minus 5x plus 1. So let me think. Numbers that multiply together to give 4. There's 1 times 4 and 2 times 2. Numbers that multiply together to give a 1. There's not a lot of them. Just 1 times 1. So I'll draw my 2 sets of parentheses. I'm going to go ahead and fill in those 1s. 1 times 1, that's all it can be. What about the signs? Can I fill them in already? Second sign is plus, so in order to get a positive, you're either going to have positive times positive, or what's the other possibility? Negative times negative, it's going to be negative. If the second rule is second sign is plus, 2 of the first sign. Minus and minus. Usually I'd be tempted to try the 2x and 2x first, but I don't think that's going to do it. What are y'all thinking? If I put 2x and 2x, I'm not going to get a 5x there. What I'm thinking is 4 plus 1 would give me a 5. What if I try 1x times 4x? How do I decide if I factored it correctly? Well, look at these inner and outer terms. We'd have a negative 4x, a negative 1x. Yeah, that's combining to give me a negative 5x. So what are my other 2 sets of parentheses? Well, x minus 1 and 4x minus 1. Any questions there? Remember doing those type of problems? So, again, what was the strategy? Well, first do the synthetic division. Then one set of parentheses is x minus k. To get the other 2 sets of parentheses, you factor that quotient. Any questions there? The next one. So we leave the synthetic division behind. I think there's some on that quiz. Okay, so we're up to number 25. It says solve this equation. Well, it sure doesn't give us a lot of hints on what to do here. Well, the variable is up in the exponent. So that means this is an exponential equation. We have 2 ways of solving those. Either a common base or using natural logarithms. If it's a common base, then your answers are going to be just integers and fractions. If it's one where there's not a common base, you're going to wind up with answers that are decimal numbers, and the instructions will talk about rounding and so forth. Okay, so for this one, it's definitely a common base. Remember that E is abbreviation for number 2.718281828 approximately. You're not going to do anything with the 2.718281828. Here we're just going to rewrite this in the form E equals E. This one's already, the left-hand side is already just E to a power. Now the right-hand side, we have one power being raised to another. So you're going to have to write that as 5 times x. There was a rule of exponents. To raise one power to another, you multiply those exponents. A to the m raised to the n is a to the m times n. So now that we have the same base on each side, the only way these can be equal is if the exponents are equal. So I'm dropping the e's and just solving the equation. 7x minus 1 equals 5x. My logic is if the bases are the same, the only way they can be equal is if the exponents are the same. And let's see, how do I want to solve this for x? This is just a linear equation, so I'll isolate the x. I'll do this little arrow notation of mine, which means subtract the 5x. So 7x minus 5x would give you a 2x on the left. Move the 1 over by adding 1 to both sides. And then divide both sides by 2. So x equals a half. So type a 1/2 in there. Do you remember doing these? Now, are we ready for another one like this? Well, yep, we are. Now, when do you do this common base? When the variable is up in the exponent. This one, number 26. The variable is again in the exponent, so let's try to get a common base. My natural thought is, okay, can I rewrite the 256 as 64 to a power? Can I rewrite that 256? And the answer to that is no. 64 squared is not going to give you 256. Okay, so let's look at the smaller number, the smaller base. My first thoughts are 8. 8 squared is 64. Right? Isn't 8 squared going to be 64? Can I write 256 as 8 to a power? If I multiply 8's together, 8 times 8 is 64, times another 8 is not 256, it's 512. So I can't write it with a 64 on each side. I can't write it with an 8 on each side. Well, let's go smaller. I'm still working with the 64. What about 4? How many 4's would I need to multiply together to get a 64? Well, 4 times 4 is 16, times a third 4 is 64. So maybe I can rewrite the 64 and the 256 with a 4. I'm trying to come up with that common base. Well, how many 4's would I need to multiply together to get a 64? I mean, to get a 256? Well, one more. Okay? If you multiplied out 4 4's, that'll give you 256. Okay? So I'm going to rewrite this, replacing the 256 with a 4 to the 4th. We still have that exponent up here, the 4x. I'm replacing the 64 with a 4 to the 3rd. We still have that exponent, x plus 3. You'll follow my logic on how I decided on the common base. I just start with the smaller base and start asking myself, well, how can I write that as a number to a power? Well, 8 squared is what immediately came to mind, but I couldn't rewrite 56 as 8 to a power. So I started thinking, okay, smaller, smaller. If you'd wanted to use a 2, I think a 2 would have worked for each of them also. By the way, I think a 2 would have worked is my way of saying a 2 would definitely have worked. Okay? You could have rewritten 64 as 2 to the 6th power, and you could have rewritten 256 as 2 to the 8th. But I'm going to leave it like this because we're getting slightly smaller numbers that way. So now, to raise one power to another, we multiply the exponents. Over here, we got to do more than just multiply. You distribute over addition or subtraction. So I'm writing it without the parentheses. And in a moment, once I've done that, I'll drop the big blue 4s. I'll have a 16x up here. And what is this? A 3x plus 9. I'm going to lift this up some. And now if the bases are the same, the exponents have to be the same. So I'm just going to set that 16x equal to 3x plus 9. And it's a linear equation, so isolate the x. I'm going to do this. I'll subtract 3x. So I have 13x on the left. And I already have the constant, the 9, by itself on the right. What do I need to do? Well, divide both sides by 13. Okay. Any questions there? Can I put it on there? Yeah. Any questions there? Do y'all remember this common base stuff? Number 27 is going to be another one of those common base problems. Ooh, this one looks a little messy because of the fact that there's that square root symbol. So what we're going to have to do here is rewrite that square root with a fractional exponent. Y'all remember how to do that? We're going to be doing it when we're working with logarithms, so I may as well state those rules. A square root, a cube root, a fourth root, a fifth root, dot, dot, dot. How do I write those with exponents? Well, that green square root symbol is the same thing as a green 1/2 exponent. This 1/3 symbol, or excuse me, this cube root symbol is a 1/3 exponent, and so forth. A 1/4 exponent, a 1/5 exponent, dot, dot, dot. So when I look at number 27, it's not like the one we just finished doing. It's pretty easy to spot what that common base is going to be. It's going to have to be a 3. So the square root of 3, I would write as a 3 to the 1/2. And then we still have that x plus 9 power equals. Now, can I rewrite 27 as 3 to a power? Well, I sure hope so, because if I can't, then this one can't be done with a common base. How do I know that? Well, there's no way you can rewrite this 3 as any other number. So how many 3's do I need to multiply together to get a 27? A 3? So that 3 to the 3rd is 27 x. And unlike the one we just did, where to remove the parentheses right here I distributed, here you don't distribute. You distribute over addition or subtraction. Over here there's no addition or subtraction. But right here, when I'm distributing this blue 3, it's over addition or subtraction. I don't think I'm going to distribute this one. I think because of this fraction, it'll be easier if we just hold off on distributing this green 1/2. If you distribute it, you're going to wind up with 2 fractions at that point. So let's just drop the 3's, the big 3's, the base 3's, and write 1/2 times x plus 9 equals 3x. That's the pink 3, not the black 3. Now, by doing that, we can get rid of the fraction from this equation pretty quickly. What would I do to get rid of this fraction here? What would I multiply both sides by to get rid of this green 2? Yeah, okay, so I'm multiplying both sides by that 2. And all of a sudden, it simplifies really nicely. The 1 times x plus 9 is just x plus 9. On the right, we have 2 times 3x. That's just 6x. That's another one of those linear equations. So just isolate the x's. I think I'm going to do this. I think I'll move that x over to the right. I'm going to isolate the x's on the right-hand side. I think that'll get us fewer negatives when we do it. If I go minus 1x from both sides, then we have a 9 on the left and a 5x on the right. Divide both sides by 5 to get the x by itself. Okay. If you wanted to move the 6x over here to the left and the 9 to the right, you'll get the same final answer. You'll wind up with more negatives in your mark. So 9 over 5. Any questions there? Any questions before we move on? Well, on the next one, I think we're going to need a calculator. Let's see, which one's the next one? Yeah. Problem number 28. It says, find the logarithm using the change of base formula. Well, I think I'm going to use my phone calculator just because that's what shows here. Okay. Some of y'all have keys that let you enter a base 2 in. But on this calculator I have, there's only 2 logarithm keys. The LOG key, oh, maybe I better do a physical zoom. And it looks like IN, but it's LN, okay? LN. When you're typing in these things, if you need to type in that thing, make sure you're typing in an L for your answer, not an I. With My Math Lab, you shouldn't hit spaces or capital letters. So this cannot be an I if there's no capital letters. Okay, it's got to be a lowercase l. So some of you have calculators that have a little key that looks like this. Log, and you can put in the base here and the number. If you have a calculator that does that, then put in a 2 for the base and a 0.12 right there. You don't need the change of base formula for this one. For my calculator, all I have is the LOG key, which is log base 10. So the change of base formula is log over log. You're going to put, you have the number 2 and then that number 0.12. The number that's written lower, the subscript, is the one that goes in the bottom. The 0.12 up on top. And if your calculator's like mine, you've got to watch out when you punch this into your calculator. I'm hitting LOG. Notice how it's open parentheses. I've got to close those parentheses. I'll punch in 0.12, close parentheses, then divided by log 2, close parentheses, before I hit equals. Oh, negative 3.0. How are we told to round this? To 4 decimal places? So can you see that? Let's see. 1, 2, 3, 4. So that second 8 is the 4th place. Am I going to leave that as an 8 or do I round it up to a 9? A 9? So negative 3.0589. This is how you punch in a base, a logarithm with a base other than 10 or an ln. If you have this key, then you don't really need that change of base formula. Okay? If you don't have that key, then you need the change of base formula. I should go ahead and mention it doesn't really matter whether you use LOG or LN. You'll still get the same final answer. Okay? Negative 3.0589. If you had punched in, this is L, ln 0.12, close parentheses, divided by ln 2, close parentheses, you're still getting the, oh shoot, what did I do? Still getting the exact same answer, negative 3.085, negative 3.0589 is how it would round. Okay? But watch out with those parentheses. If your calculator opens them, you're going to have to close them. That's called the change of base formula. Okay? Any questions there? It's one of those problems that you just need a calculator for. Sometimes students say, well, what if before calculators there were huge tables? Find an old algebra book and you'll see a lot of tables in it. Okay? Now 29, we're up to expanding logarithms. It says use the properties of logarithms to expand them. And this is some of that stuff. It's going to take longer to type in your answer than to do the problem. Okay? In order to expand logarithms, if you have any of these radical signs, a square root or a cube root, you need to rewrite them with fractional exponents, like I did here. A square root is a 1/2 exponent. A cube root, a 1/3, a 4th root, a 1/4, dot, 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 it goes on and on. Okay? The first thing we're going to have to do on this one is rewrite, I'm going to write log, that's a base D, S, T to the 8th, R to the 6th. I've got to rewrite this square root as a 1/2 exponent. So that's what I'm doing first. And that's really the only work I have to do before I just start writing out the answer. If you can tell the color, I have the square root in green. So I'll put a green 1/2 exponent. I know up there on the projector the color doesn't show so well. It shows better on a computer screen or something. So to separate and expand these logarithms, you separate at multiplication and division. So let me put the red dot. There's multiplication right there and division right there. Just think about the time the student told me, you seem to think that's important, putting those red dots and stuff, and I don't understand why that's important. It's incredibly important. If you can't put those dots or the division symbol, then it can't be separated. You can't expand it. As it stands, I'm going to expand this into 1, 2, 3 logarithms. How many minus signs am I going to have? Just one. So getting started, the exponent goes in front of the letter L. So I write 1/2 log base D of S. Typing this stuff in can be a little tedious. It's tempting to forget to put in that base. Plus 8 log base D of T. Then in the bottom now, anything in the bottom has a minus in front of it, so a minus 6 log base D of R. Typing it in takes a little bit of time, doesn't it? Okay. Any questions there? This is called expanding logarithms. I think whenever people see this and start typing it in, they never once think capital I-O-G. However, they see the next one. So often people type in capital I instead of an L. There's no time you should ever be typing capital letters on My Math Lab. Okay? So if you shouldn't be typing a capital, then this can't be a capital I. It's an L. Logarithms always begin with what letter? L. Logarithm begins with the letter L. That's an L here, not an I. If you type it in with a capital I, it's going to give you the wrong answer. And I can look at what you've done and spot immediately, if you're typing it incorrectly, it should bold it when you type in LN in your answer. So let's look at this one. I'll write it out. LN, I'm using cursive L on these just because I don't want it to look like a I, capital I. X to the 7th. That square root, I'm going to have to write as a 1/2 exponent. So I'm rewriting this square root, if it were green, as a green 1/2. And then we have an x plus 1 to the 7th on the bottom. So the first thing you do is rewrite the square root symbol with a 1/2 exponent. And now it's time for those red dots and red fraction bar. You separate at multiplication and division. So where's the multiplication? Well, right there. That's multiplication. And there's no other multiplication, but there is division right here. This is going to separate into 1, 2, 3 logarithms. You can't separate at addition or subtraction. So this x squared plus 1 is going to stay at x squared plus 1 in parentheses. The x plus 1 is going to stay an x plus 1 in parentheses. Now, I'll just start writing out the answer. Thinking, wow, it looks like he just wrote the problem down and wrote the answer. Yeah, that's what I'm doing. I'm sure if you click on View an Example, you'll see a lot of steps. Not what I recommend you do, but that's up to you. So I'm doing that x to the 7th first. The exponent goes in front of the letter L in x. then a plus because we're still on top. The exponent goes in front of the letter L. That x squared plus 1 has to stay together. You can't separate it in any way. And then a minus. Why minus? Well, we're in the bottom. The exponent goes in front of the letter L. And then the x plus 1. We type it in exactly like that. Don't get carried away thinking you can distribute something here. No, 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 you cannot separate the x plus 1 or the x squared plus 1. I'm going to leave it all together. Any questions there? In algebra, you always do stuff one way, then you do it in reverse. Here we were expanding logarithms. Next, we'll condense them. Oh, make sure you're typing an L on this one. Okay, if you type in an I, it's going to count it wrong. Any questions there? Number 31, we are going backwards. It says express as a single logarithm. So our answer here is just going to be one logarithm. Log base b. We only want log written once now. This formal name is condensing. I think on the next problem they say the word condense. You expand logarithms, that's when you go from one of them to more than one, here 3. You condense logarithms if you're going backwards. Well, to condense logarithms, I always ask myself, will there be a fraction bar after the logarithm? Will there be a fraction bar? Well, no. Because of that plus. If that circled plus were a minus, then I'd be drawing a fraction bar. Since there isn't a plus, I'm just going to write 18 and 8. What's the operation between these? Multiplication. Don't put a plus there. If you put a plus, they couldn't have been separated into two logarithms. This is 18 times 8. And looking at this, it's hard to read what the heck I just wrote there. That's the 18. That's an 8 right there. So we can actually perform that operation. 18 times 8, let's see, that would be an 80 plus 64. Is that a 144? 18 times 8. So, let me write it up here. Log base b of 144. Any questions there? Well, it's a pretty short one. Are we ready for another one? Problem 32. Oh, well, at least this one's multiple choice, so that means you're not going to have to type the stuff in. But let's see, it looks hard, right? It can be real intimidating when you first look at it. Use properties of logarithms to condense the logarithmic expression, right? The expression is a single logarithm with coefficient 1. What do they mean by that? Well, when you're condensing, you don't have a number in front of the letter L. That's what it means by coefficient 1. We didn't have a number in front of the letter L. There's an assumed 1. That's it. Where possible, evaluate logarithmic expressions. That's not possible. So how would I go backwards here? Well, I'm going to write down log base 5. And the first thing I do when I'm condensing logarithms is to always ask, will there be a fraction bar after it? Let's see. Will there be a fraction bar after this logarithm? Yes, because of this minus right there, not the r minus 7. This minus here. So I'll put the fraction bar. Now, the number in front of the letter L, that's the exponent. So this would be, the 4 is an exponent. So you have a 2 with the 4 as its exponent. This 1 over 7 is the exponent. So we have the r minus 7 with the 1/7 as the exponent. And what do we have in the bottom? R, the 1/2 is the exponent. R to the 1/2. The exponent is the number in front of the letter L. So 4, 1 over 7, and 1 over 2. Well, this isn't listed as one of the multiple choices. So let's see, what else could we do? Well, the 2 to the 4th is not 8. What's 2 to the 4th? 16. As soon as you know that, you can knock out A and D. It's either going to be B or C. Well, remember what these little fractional exponents mean. And that'll help you figure out whether it's B or C pretty quickly. There was my little statement of the, right here. A 1/2 exponent is a square root. A 1/3 exponent a cube root. Dot, dot, dot. A 1 over 7 exponent would be a 7th root. Is that showing up there? Okay, so 1 over 7 exponent is a 7th root. So we should look at the answer should have a 16 in it, a square root in it, and a 7th root in it. There's only one answer that has a 16, a 7th root, and a square root in it. See? As soon as you get to this point and you realize, oh, 16, that knocks out A and D. And then if you remember what these fractional exponents are, a 1/2 means square root. Well, if you knocked out A and D, there's only one of them that has a square root in it. C. A 1/7 means 7th root. Okay. So it is answer C. Okay. Any questions there? Well, I think I made this video longer than I intended to, so I think now we'll take a little break and we'll finish this up. There's only a few problems remaining, so we should get it done in one more video. So, any questions over that? But then, this is Mr. Precella. Thanks for listening or watching. If you're leaving the actual class that's out there, then the videos will be posted. I'll finish it up today and get them posted today. So thanks for watching. Bye-bye.